So we're told that w is equal to minus 1 plus the square root of 3i. It's a complex number where I squared is equal to minus 1. And part 1 asks us to write w in polar form. So in order to write z in polar form, we need to write it as z is equal to or cosine theta plus I sine theta, where or is equal to the modulus, and theta, the angle, is the argument. So first of all, finding or. Modulus of z is equal to the square root of x squared plus y squared, when we have it in rectangular form. So x squared is going to be minus 1 squared, and y squared is going to be the square root of 3 squared. So we're going to get the square root of 4, which gives us 2. So now to find the argument. So we're looking at the angle that's created with the x, the positive side of the x-axis. So we're looking for that theta. In order to find it, we're going to look at the right angle triangle on the other side. So if I just make a sketch, I'm going to call this theta 1. W I know is minus 1 plus the square root of 3i. So my distance here is 1. And my distance on the imaginary axis is the square root of 3. Or I have minus 1, sorry, and the square root of 3. So I use tan to find the angle. So the tan of theta is equal to the square root of 3 over 1. So therefore theta is equal to tan inverse the square root of 3 over 1, which gives me minus 60 degrees. We want it in terms of pi, so we have minus pi over 3. So if we look back at our Argand diagram, that's not the angle we're looking for. We're looking for this angle here. So just using our straight line rule, if we have an angle here, theta 1, we're looking for theta 2. We subtract theta 1 away from 180 degrees and we'll find our theta 2. So the angle that we're looking for is going to be 180 degrees, which is pi, minus pi over 3, which gives us 2 pi over 3. So therefore w in polar form is going to be 2 cosine 2 pi over 3 plus I sine 2 pi over 3. Part 2 asks us to use de Moivre's theorem to solve the equation x squared is equal to minus 1 plus the square root of 3i, given your answers in rectangular form. So if we know that z squared is equal to minus 1 plus the square root of 3i, then z is equal to minus 1 plus the square root of 3i to the power of a half. So we need to use de Moivre's theorem. So using our polar form, we know that if z is equal to 2 cosine 2 theta over 3 plus I sine 2 theta over 3, so we're obviously taking this from part 1. If we have all of this to the power of a half, then we apply that power to the modulus, so that's going to be 2 to the power of a half. And we multiply that half by the argument. So it's going to be 2 pi over 3 multiplied by a half plus I sine 2 pi over 3 multiplied by a half. So because we're trying to solve the equation z squared is equal to minus 1 plus the square root of 3i, we need to write it in general polar form. So in general polar form, we have 2 cosine 2 pi over 3 plus 2n pi plus I sine 2 pi over 3 plus 2n pi. And that's everything to the power of a half. So again, De Moivre's theorem tells us we apply the power to the 2, so that's going to be 2 to the power of a half. And we multiply that half by the argument. So we're going to have cosine 2 pi over 3 plus 2n pi and that's divided by 2 because we're multiplying all of it by a half, plus I sine 2 pi over 3 plus 2n pi, again everything divided by 2. So in order to find our two answers, we first of all let n be equal to 0. When we let n be equal to 0, we're going to find the square root of 2 multiplied by cosine just pi over 3 plus I sine pi over 3. So just to note, if we look back down at the bottom left hand corner, if n is equal to 0, then I have 2 pi over 3 divided by 2. So that's where I get my pi over 3. So this is equal to the square root of 2. Cosine pi over 3, I get a half. Sine pi over 3, I get the square root of 3 over 2. So just to simplify, I get the square root of 2 over 2 plus the square root of 6 over 2i. So now I let n be equal to 1. Z is equal to the square root of 2. So when n is equal to 1, this is going to simplify to give me 4 pi over 3. So I have cosine 4 pi over 3 plus I sine 4 pi over 3. This will give me the square root of 2 by minus a half minus the square root of 3 over 2i. So if we simplify, we're going to get minus the square root of 2 over 2 minus the square root of 6 over 2i.